So welcome everybody to this ACES short course, Data Science in R. Um, it is a almost a full day uh, in length. We'll be going until about 4 o'clock this afternoon. So let's go ahead and get started. What we're going to be covering first is getting onto ACES. And once we get onto ACES and ensure that everybody's able to access that portal, we will be launching a interactive app called Tutorials on Demand, which is where we'll be working today. We'll be talking about data structures in R, uh, briefly going over the tidyverse of applications, importing and exporting data. We'll be doing simple regression, principal component analysis, and then we'll end the day with data visualization with ggplot2. So if you could, please make your way to hprc.tamu.edu, and in the menu at the top, select Portal, and then ACES Portal Access to log on to the ACES portal. Looks like most people are able to get on though, so let me go ahead and do the same. All right. So now that we're here, what we're going to do is we're going to go to interactive apps and scroll down, and you'll see we do have RStudio here. Do not click on that. It's the same interface as on your computer. It's just got a much more powerful backend with ACES being what it's running on. We're going to be running tutorials on demand. So click that. In this drop down, select Data Science in R. Set the number of hours to 6. Then click Advanced Options, and under Reservation Name, click R_training. Now this application is always available, so if you have an allocation on ACES, you can always access this. If you do so in the future, you won't need to put in the reservation name. We are just ensuring that everybody here can use some portion of ACES that's been set aside for today's training. All right, so once you have all of these set, you can click Launch. And it will take you to a screen that looks like this. All right, and once you have this button appear that says Connect to Tutorials on Demand, Data Science in R, we can click on that. And then we should see this new window pop up that it looks somewhat like a Jupyter notebook with our R short course training materials for today.
Oh, sorry, excuse me.
No, yes.
Can you repeat what's the node name?
What is the node name?
Yeah, in advanced setting.
Um, do, do, do. No, we don't put anything for the node name, just our training for the reservation name.
Oh, okay, thank you.
Yes. All right, and can I get a thumbs up once you reach this screen here? All right, if there are no objections, we can go ahead and get started in the notebook. And Young Hee, once we get you added, you can just follow along until then. Then we can have somebody help you get on and make sure that everything's set up correctly. All right, so what we're looking at is a notebook built using the R package Learn R. And what it allows you to do is essentially take an R Markdown file and transform that into this style of notebook that allows you to put in both texts and tables and also code cells to run different bits of code. So it's really good for teaching and covering all these different topics. You can see we have all these topics that we'll be covering over here on the left, and you can click on these as we go through. We're going to be starting off with data structures, and these are essentially like Excel spreadsheets where we've got rows and columns of data that can have, it can be a mix of, character data, like labels, logical data, and numeric data. So I'd say data frames and tables, which we'll talk more about later, and vectors are probably the most commonly encountered data structures in R. All right, so let's go ahead and get started running some code. Whenever we are working with a data object, whether it be a vector or matrix or data frame, there are a lot of ways to do kind of an exploratory analysis or just view the data really, get a simple overview of what the data contains. My favorite command for this is the str function or structure. And it allows us to look at the structure of a given data object. Head displays the first few components of a data object, and print will print the entire data object. So already spotted my first typo here. All right. So what we're going to do is run all three of these commands. You can click this Run Code button up here, or Control R. All right, and so the output is down here. And so for the str command, it shows us that it's a data frame. All right, Iris is a built-in data set that comes with R, and it contains various flower measurements. And so we can see here we've got 150 observations of 5 variables. So that's 150 rows with 5 different measurements. So sepal length, sepal width, petal width, and the species. And then it actually starts to show the contents of each of those columns, and then ends with the ellipses once it runs out of space. So there's a lot of information packed in here. We've got our column names, the data structure type, the overall dimensions. And so that's why it's my favorite command to look at data objects. It gives you a lot of information and a very small output. Head's going to print off just the first 6 rows of the data set. So again, we see our column names here, sepal length, sepal width, petal width, and then the species. And then if we do print, we can see that it prints out everything. All right, so this isn't a huge data set, only 150. But if you try to print something with 10,000 lines, then you'll be there for a while, and it'll eat up a lot of space. All right, so I'm going to give you a few minutes to use those built-in functions we just learned about, and on the dataset mtcars. All right, and I see I've got a question. So feel free to unmute and ask away.
All right. Yeah. Thank you very much. Just a quick one. I'm trying to find the XTR function. Does that also mean it loads the data? I'm trying to like figure out where the iris data set was loaded from in this
Ah,
code.
yeah, wonderful question. So the Iris data set is built in. There's a lot of built-in data frames. Iris is a very, very popular one. MT cars is another one. In fact, if you type in uh, data, uh, there are a lot of built-in data sets. Uh, so uh, for this notebook, we have actually a bunch of packages already loaded, including like TidyR and ggplot2 that have their own built-in data sets. And so this is just showing you all of the uh, uh, data sets that are available in the various packages that are currently loaded. Iris is built into the base R though, so it's always available no matter what packages are loaded. All right, so if we just type in these three commands and run this code, and now we can see we have a data frame with 32 observations of 11 variables. These are our column names. Again, MPG, the number of cylinders, the displacement, which is the engine size, and so on. Head, again, prints out the first 6 rows. So we can kind of see what the very top of this data frame looks like. And it's going to do so in a nice looking fashion. Print is just going to print everything out to screen. But again, a very small data set, so not that big of a deal. All right, any questions on examining data frames or data objects? All right. All right, so let's move on and talk more specifically about vectors. So these are one of the most fundamental data structures in R. They are essentially what's used to build like data frames and tibbles. Each one of these columns would be, in a data frame would be considered a vector by itself. So we have really four main types of vectors. Uh, we have logical, again, true, false, integer, uh, which in R we have to denote integers with a capital L. We have just general numeric type, and finally character data. So uh, words, various symbols, and those are going to be the elements inside of those vector types have quotes around them. All right, so we can create vectors in R using a few different uh, methods. I think the C function, the combine or concatenate function, is the one that is most often used. It's got the most utility. And so all we're doing here is we're using that C or combine/concatenate function to create a new vector with all of these elements inside of it. All right. And so if we uh, create this new vector and then run our structure command on it, we can see it is a numeric vector, dimensions 1 through 8, and then it actually prints out all of the contents of that vector. All right, since there are, we have a lot of beginners here. What did we do up here with num_vec? So here we're actually creating a new variable to contain all of this data, and we assign it with this single equal sign operator, which shouldn't, it's not a difficult conceptually, but something you will see in R as well is this operator, and really fundamentally they work the same way, and it's really just a matter of preference. So you'll see this a lot whenever you're looking at code for assigning variables. It's either that or the equal sign. They both work for all intents and purposes the same way. All right, so now we have time for an independent exercise. Use the code chunk below to create a new character vector that contains the days of the week. Save the vector as a variable named week and examine structure using str. So I'm going to give you a minute or two. And if you are brave, go ahead and throw your solution into the chat whenever you get it. And we can share it that way, and we'll give it a go. So I'll give you a minute or two to do this. And again, once you're finished, please, if you can, share your code in chat. Excellent. All right, so I see. I'm going to go ahead and just copy this one from Yuying and put it in here. All right, so Yuying has used the less than dash operator to assign the output of the C function to a variable named week_vec, and then structure for, oops. Excellent. All right. So I see of the three responses we got, one used the equal sign operator and two used less than dash operator. Again, that's a personal preference, so not a problem. And but everybody started the week on a Monday. It's interesting. All right. Real quick, you can throw in chat your preference. We'll do a quick poll, informal poll, and see if you prefer this operator or the equal sign operator. I'm always interested in that. Or no preference.
Yeah, just curious to know,
Oh yeah, go ahead.
would anyone work on R program itself? Like if I'm using the R Studio, would equal to also mean using the less than dash operator? Would it
Yeah,
also mean same?
they mean the same thing.
All right, because I use the equal to a lot on Python, so I just wanted to know if it would mean something different. So I
Yeah,
don't know
no.
really. Equal to is
y-
fine, but for convention, I would go for.
Yeah, and I prefer the equal because I also work in Python as well. So it's just what I'm used to more. All right. All right. Yep. Got a little bit of split, so that's fine. All right. Let's go ahead and move on to subsetting vectors. And that's when we pull out a element or multiple elements from inside of a vector. And so vectors in R are ordered. And so if we put in here Ying's code that we want to pull out the first element it will pull out this Monday. And so we indicate that with square brackets. So here we're saying print the week and then print from week the first element. All right. So here we're starting with Sunday and ending on Saturday. That's the week vector that's stored there. And the first element is Sunday. All right. So how does this differ from like Python or maybe some other programming languages?
Just a quick one. I'm sorry.
No, I'm asking. Yeah, go ahead.
Okay, yeah, the first question you asked, I think how it differs is that Python will read the index from zero, meaning
Exactly.
the first index. And yeah, the difference I see is that you're printing week as the variable, but the earlier variable that was set was week underscore vec. So I'm wondering, is there something different?
Okay. So you're asking why we didn't use this?
Yes, was there an earlier variable set as week? So I just wanted to know if week was earlier used, and I was wondering why.
Yeah, okay.
So,
No.
yeah.
Let's try this. That's a great question. So, all right. So it says object week underscore vec not found. And that's just because of the way the notebooks are structured and written. Um, so there's a lot of stuff on the back end behind, like you're seeing like the rendered version of the notebook. There's a lot of code underneath it that dictates uh, what variables and what data is available for what code chunk. So it's not really uh, it's more of how the tutorial is made rather than anything else as to why we used week there. Week was already built in here because of the way I coded it. Does that make sense?
Yes, yes, that makes sense. I think it was going to validate my next question if because earlier it printed Sunday, so I wanted to know if that means the week that was preset in the training was probably set as Sunday for the first day of the week.
Correct.
So I get it. Yeah.
Okay, yeah. So if we go ahead, I'm gonna go ahead and grab this. All right. Thank you. That's a good question. These are so if I put this and then we can do all right. So I hope that clears it up. Um, uh, we are still pulling the first element, but the order of those elements has changed because of a slight difference in the way the vector was created. And so again, in R, we start counting or indexing at 1, whereas in like Python, this would be like the 0th element. And so just a small difference between the two languages. Just so if you're coming from Python, be aware. All right. We can also select multiple elements at once, right? We're just pulling the singular one here. Um, if we want to say print the first 3 elements of a vector, we could do so with something like this. Excuse me, print week 1 through 3. All right, and so that's going to print off Sunday, Monday, and Tuesday. All right. So this is another way to create a vector is with this colon operator. But you could also provide a vector like this. And it would be the same thing. All right. So if we want to let's see now, so this exercise, we're supposed to print the elements 1 through 3 of the week using the C function, that combine or concatenate function, which we've done here, and then print elements 4 through 7 using the colon operator. All right, so and now you can also see that we've printed off Wednesday through Saturday. One thing to note is that this syntax is inclusive, right? So it's pulling all the way from 4 up to 7 and including 7. Uh, and in certain situations in Python, that may not be the case. So it may pull up to and stop right at 7. So you'd have to go to 4 to 8 or something like that. Okay. Any questions on subsetting? All right. We can also use this syntax to drop elements from a vector if we put in a dash or negative sign in front of them. So here we are taking week and we are dropping elements 2 through 6, and we're saving that as weekend. Excuse me. And if we run this code, now it should just say Sunday and Saturday, the 1st and 7th elements of that vector. All right, so to subset data frames, we use a very similar syntax, but now we have to account for having both rows and columns in the data. So to do that, we have to include commas whenever we're specifying what elements to select. So here, if we have some data frame and we want the element that is in the second row and the 4th column, we use this syntax here. So the row goes first, the row index, and then the column index. Similarly, we can get multiple elements from a data frame. Here we're saying rows 1 through 2 and elements from those rows in columns 5 and 6. All right, to select everything in rows 1 and 2, we can just put 1 through 2, comma, and then leave the next part blank. That will select everything in rows 1 and 2. And finally, you can select entire columns from a data frame using the $ operator. So this is something I think that's really nice in our is being able to pull out these full columns just by specifying the data frame name, the $ operator, and the column name that you want. All right, so let's put all of that information I just threw at you into action so you can practice it. In the code chunk below, use the built-in data frame empty cars to complete the following steps. Look at the structure and first few rows of the empty cars data frame. Then select the first two rows of the empty cars data frame and save it as a new variable Mazda, and then print the contents of the new variable. Select the first and second elements of rows 4 and 5, and save the output to the variable Hornet and print the contents. And finally, calculate the overall average miles per gallon using the $ operator. All right, that one might be a little bit tricky if you're new to R. Um, is it higher than the median miles per gallon? All right, so go ahead and start working on this. I'll give you a few minutes, and please, again, once you have a solution or even a partial solution, that's completely fine. Throw your code in the chat just so I know where everybody's at and making sure everybody's keeping up. So I pulled this one from the chat. So let's see. Let's run this. All right. All right, great. We've got the structure and used head to complete step 1, which is correct. Right. So now we can see this same structure output that we saw earlier. For elements. Uh-oh. All right, so here, select the first two rows of the empty cars data frame and save it as a new variable named Mazda. We need to put in a comma here because we got columns, the first two columns instead of the first two rows. And so you see this unexpected comma pops up. It's fine. This is the correct syntax. That's just the learn R package being weird. All right, so let's rerun this. All right, so now we've got the first two rows. That's named Mazda. That corresponds with the Mazda RX-4 and the Mazda RX-4 wagon. So that's good. And then finally, Hornet is equal to empty cars, rows 4 through 5, and columns 1 and 2. All right, and then print Hornet. Let's look at it. Excellent. Excellent. All right. So we have one more step that we need to do. Has anybody figured that out yet? If you are new to R, I do not blame you for not having this figured out. All right. So in R, there are a lot of built-in functions, especially around like basic statistics and numerical functions. So one of those would be like the mean. So if we do, what is this asking to do? All right, calculate the overall average miles per gallon using the colon operator. All right, so if we do, excuse me, we can do print, is it mean? M C cars MPG. All right. And so we see now that the mean is 20.09. All right. Now, that's just printing out the number. Let me show you something now to maybe make this easier to interpret. What we're going to do is use another function called a paste function. And that allows us to put two things together to be printed. So I'm going to paste together the average MPG and the output. All right. And so now we've got this output that says the average MPG colon, and then gives us the actual value that we calculated. All right. So again, the syntax for that is we have to paste these things together with the paste function. Um, and then I gave it the string I wanted to print out and then the value I wanted calculated. So if we just copy this and make some small changes, I believe the function is median. You can see it pop up as we type out median. All right, and so now we can answer the question and say that the average is greater than the median. All right. Are there any questions? All right, so we did median and mean. There's also, since, uh, again, since we have a lot of beginners, I'm going to go ahead and show you some other built-in functions. Uh, Not that the sum of the MPG matters, but just so that you're aware. Doo-ba-doo. Oh, oh no, I'm missing a parenthesis somewhere, or an extra parentheses. There we go. All right. Uh, Standard deviation is 6.026. And the sum is 642. Not that that really means anything, but there are a lot of built-in functions like that, statistic functions. You know, get the standard area, the variance, uh, and there's even like trigonomic functions like sine and cosine. There's built-in values like pi or infinity. Um, there's a long list of functions that really give base R without any additional packages um, a lot of numeric capabilities.
Yeah, just a very quick one. Uh,
Yes.
is there a way to like run a code that calls out of the function, or we could just get that from like our documentation, like the way we did the data parentheses, and then can we like do a function parentheses that shows us all the available functions, or I can
Oh,
just
you
always learn
want
that from docs. Yeah,
to, is there like code to get all the available
yeah, like
functions?
the way we can do like Python help something like that. If there's
Um,
nothing like that, it's fine. I mean, I can always
no,
get
no,
the
that's a good
documentation.
question. Uh, hmm. So let me try this. So if you're just looking for something, um, No. I don't know. I always just Google it. It's quicker. But that's a good question. Uh, so the lsf.str, if you provide it a package, um, it can work. Let's see. Ah, okay. There we go. Great question. Um, so these are all of the base functions available in R. All right, I learned something today. Thank you very much. All right. So, without any objections, let's go ahead and um yeah, let's just talk about tables versus data frames. Um, so tables are kind of a uh, reimagined, more opinionated version of data frames um, that are generally used in the tidyverse of packages. So the tidyverse is uh, a suite of very commonly used packages. So things like ggplot2, dplyr is a very popular one. There's uh, like Excel imports packages from Tidyverse. There's a suite of different packages that all kind of use this Tibble as the main data structure. Uh, they are very, very similar to data frames and really you can almost use them interchangeably. Uh, there are a few different uh, ways in which there are a few different differences in the ways in which they behave. Um, so for example, using the print function will only display the first 10 rows of a tibble, whereas with a data frame, it will print the entire thing. Uh, if we're trying to, oh, did I miss something? No. Okay, I'm sorry. I'm sorry. ADHD moment there. Um, so if we're selecting something from a uh, Tibble, like say a column name or using some character string to try to match something in the Tibble, it won't conduct partial matching, but data frames will. Uh, if we subset with the square brackets and a Tibble, it's always going to return a Tibble, even if it's would generally return a vector with a data frame. Uh, Tibbles do not alter input types. They also only recycle vectors with a length of 1, which I'll show you what that means in a minute. And Tibbles cannot generate the names of rows. So if we'll take this empty cars data set that we've been looking at, and first we'll save it as df_mt, so we know it's a data frame. And then next we're going to convert it to a Tibble and save it as tb_mt, and just print off each. So again, a Tibble it's only going to print the first 10 rows. A data frame is going to print off the entire data frame. All right. So if we go now and subset the data frame, it's going to return a data frame. When we subset a tibble, it will return a tibble. Here, if we subset a data frame, it's actually returning a vector. Whereas when we subset the same thing in a tibble, it returns a 6x1 tibble, right? So it's not going to return a vector for you. You'd have to transform it into a vector. And finally, if we do print df underscore mt $MP, it'll do that partial matching and actually print out the MPG column. Whereas with a tibble, it's more opinionated. It will not do the partial matching, which is something I actually prefer. So that's good. I think that is a good place for us to pause and take a break. Victor, can you throw up the break slide? And we'll be back at 11:20. All right, welcome back, everyone. All right, so let's go ahead and move on to mathematical functions with data objects. All right, so real quick, our mathematical operators in R are as follows. Addition, subtraction, the plus symbol, minus symbol. Multiplication is just the asterisk or star. Division is a forward slash. Exponents are the caret. And finally, to get the remainder of after division, it's 2% symbols. All right, so there is already a vector coded in to this code cell called heights. All right, so looks like it's heights in it's meters. So what happens if we just do something like heights times 2? All right, so it looks like it's just going element by element and multiplying each by 2. All right, pretty straightforward. Heights minus 2. All right, plus 2. What about heights divided by 2? All right. So what's happening is that heights is a vector and R is going through and applying that operation to each element inside of the vector. All right. Now, what happens if we want to perform these same mathematical functions whenever we're looking at two different vectors? All right. So we have an independent exercise here. It says use the code chunk below to complete the following steps. 1, create a numeric vector named num underscore vec underscore 1 with numbers 1 through 6. And another numeric vector named num underscore vec underscore 2 with numbers 7 through 12. Multiply the two vectors together and examine the results. Then remove the last 3 elements from vector numvec2 and multiply the vectors again. And finally, remove the last element from numvec1 and multiply the vectors one last time. All right, so I'll give you a few minutes to write that code. And once you have done so, please go ahead and share it in the chat. That way I know that our pacing is correct and everybody's having enough time to complete these exercises. All right, so we've got the creation of our two different number vectors, and we're going to print those out. So let's go ahead. I'm going to add in print numvec1 and print numvec2. And I'm going to comment out 4 and 5. So what does the hashtag mean here? Or octothorpe, if you're Josh? All right, so we're just commenting out that line. So that code's actually not going to be run. That's why Nick here has got hashtag 1, and so that he just is labeling, essentially labeling his code, putting comments in it. That's step 1, step 2. All right, so then we've got our first vector and our second vector. And then when we go through to multiply it, what R is doing is going through and multiplying 1 times 7, the first elements from each vector, and it's 7. Then 2 times 8 is 16. Then 3 times 9 is 27, and so on. So let's see what error this gives us. Incorrect number of dimensions. Let's try this. All right, so it didn't like that combination of removing elements and not. Yeah, I'm not sure why that didn't work. But it does work if we just save it as a new vector named numvec2. So two things thrown in chat. Oh, three things. Okay. So I don't think that -4 colon -6 would work. Uh, and Joe Fay said should be 6 elements. All right, so and that's no, it doesn't have to be. In fact, what happened here, uh, we got our first when we multiplied again with just a vector of length 3. It's 1 times 7 is 7, right? 2 times 16 is 8. 3 times 9 is 27. All right, and then 4 now goes back to 7, right? Because our vector is 7, 8, 9. And so that vector that's the shorter length is going to be recycled. All right. Yeah, okay. All right. All right, and then all right, so Nick, let's try your solution for this down here. Oh, that did work. Wait, no, it didn't. Oh, let me see. Okay. All right. So in the original one, it was like this. So that did work, Nick. Good job. And it should have been that if we wanted to list out the numbers. All right. So both of those we're going to create a vector, but so that we're using the C if we're listing out each element that we want, or that colon operator does work with the negatives, which I didn't know it did. So that's cool. But that operator itself doesn't need, it's creating the vector as well, but it doesn't need the syntax of like the C and then parentheses to do so. Does that make sense?
Yeah.
All right, cool. Yeah. Yu Ying actually showed us that in the code they provided. So fantastic. All right. So actually, but now let's look at what happened. All right. Uh, it actually went through and didn't throw an error. It only threw a warning. Whenever we printed off a vector of length 5 times a vector of length 3. So it started recycling, but said the longer object length is not a multiple of the shorter object length. But it did produce a result and only gave us a warning. So if you're doing these types of manipulations on data frames or something like that, or calculations on these data frames, make sure that you're looking at your output because it may continue to run and not throw an error. If this were the case, I would want it to throw an error rather than just a warning. I can't imagine recycling or conducting any sort of calculation where having the shorter one not be a multiple of the longer one, where that would be useful. So if you're running something like this, like is an R script, just make sure you're looking at your output and reading through all of the different warnings and things like that to make sure your code is behaving like you want it to, and not just not just completing the run with inaccurate results because of some weird indexing issue. All right, so we covered this a bit earlier. All of our different mathematical functions built in the base R package and values. So if we just look at some of these again, using the heights vector, so we can see we have an average height of 1.72 meters. So this syntax is, again, the function, and then in parentheses, the data object that we want to do this calculation on. Variance. All right. So 0.0299 is the variance. All right. So the last little code block in this section on data structures is an independent exercise. And it says use the code chunk below to convert the heights vector from meters to inches and save it as a new variable named inches. And then calculate the mean and variance of the new vector. All right, so I'll give you a few minutes to do that. And then again, once you're done, throw your code in chat. It's good to see everybody's different approaches. All right, we've got something from Nick. Oh, excellent, including a paste function. This is a nerdy thing for me to get excited about, but so be it. All right. We got M to N. What just happened? All right. Is we're setting is a value of 39.37, and inches is equal to heights times that. Inches mean is being saved as the output of the mean inches. All right, yes. So we run this. Ah, all right. So the mean is 68.066355555555 inches. All right. Let me throw in a round function. All right. So thank you, Nick. That was awesome. Uh, I liked the paste. What I did was I added in an additional function, the round function. And then I did something else that we haven't seen before in one of these functions. And I threw in another flag. And this one was digits, setting that equal to 2, meaning it's only going to give me those 2 digits after the decimal point. So it cleaned it up a little bit and made it nicer to read. Nick already did a great job with using that paste function to give us meaningful output. Are there any questions?
I have a quick question.
Yeah.
Is there a way in the print statement to do what you did with round, or is the best way to do it just doing it in round above?
Oh, I mean, you could put the round function here. If I could type. No, my goodness, stop suggesting things to me, please. And then if I remove this up here, all right, so it ran, right? I think here is just a matter of preference as to what you like better. We can obviously still include that additional flag, because right now it cut it off as a whole number, right? Oh, I see what I did. All right. So, great question. Either way is fine. It's just a matter of where you want to put the round function. All right. Any other questions? All right. If not, let's go ahead and move on to the next section, dplyr. So it may seem weird that I'm devoting an entire section to a specific R package, but this one is a very valuable R package for data manipulation. essentially it's kind of a standard now to use this package in data science. So I figured I would cover some of the different aspects of using dplyr. All right, so like we said earlier, dplyr is part of the Tidyverse, and it uses tibbles instead of data frames. So the tibble that we're going to be using is actually one that's built in with the dplyr package called Star Wars. So before we get started, there's also another operator we need to introduce that's not specific to this package, but definitely used in conjunction with this package quite a bit. And that is this pipe-like operator from the package Magritte R. And essentially this works as a pipe feeding data from the left side of the input to the right. All right. So in this code example here, this line right here, where we're saying head Star Wars, is equivalent to running Star Wars and then piping that into an empty head function. So if we run this, the output's going to be exactly the same, right? Because they're functioning exactly the same. It doesn't make a lot of sense to do that here. This is actually cleaner. But if you remember, like those round functions and the var and mean functions that we looked at the very last example, whenever you start putting those functions inside of functions inside of functions, code can get very ugly very quickly. So as an example of this, this section of code right here is equivalent to this, right? And so here, what we're doing is it's hard to read. First, all right, I think our inner parentheses start here. And we're subsetting this data frame to grab species only belonging to Setosa. And then it looks like it goes to a summarize function where we calculate the mean sepal length. And then finally to a round function where we're asking for 2 digits. All right, and this pipe-like operator cleans this up and makes following the order of operations very simple as to and it's much easier to read is what's happening. So here we're saying our Setosa mean sepal is equal to iris piped into the subset, and then we're taking that subset and piping that into this summarize function, and taking that summarize output and piping that into a round function. All right, so do you see how both are technically correct? One would be preferred as far as like sharing code and increasing readability. Does that make sense to everybody? A thumbs up or thumbs down? All right. If you'd like me to re-explain or go into further detail, I'm happy to do so. Just interrupt me, post in chat, raise your hand or whatever.
I have another quick question. Sorry.
Yep.
So
No, no problem.
yeah, for the pipe argument, like in this example here, you have iris and then the pipe to the subset. But subset I know has, well, maybe it has more, but from what we've learned, it has 2 arguments. The first one, which is the data frame, and the second argument, which is the kind of how I guess we're subsetting the data frame.
Correct.
But this seems to know that with this piping architecture that iris is the first argument of subset, and we don't have to specify that.
Correct.
Is that just how, does it always assume it's the first one, or does it just automatically try to detect that?
Yeah, so essentially you have the syntax that it's expecting is yeah, subset, and it's the data object that you're doing something on, and then your conditional operator or conditional comparison. And so yes, that's how the pipe is working. That's exactly right. And so we don't need to specify again that iris is going to be the data set that we're doing this on, because we're piping it in and it automatically picks that up. So it does look a little weird at first, especially if you're used to using like the subset command in a different way, or without this pipe-like operator. But once you get used to this, it does make more sense intuitively, I think, or make sense intuitively. So, but yeah, it's just a matter of getting used to the differences in syntax. But that's a
Okay,
great
thank
question.
you.
Yeah. All right. So this pipe-like operator works really well when we're chaining together a lot of these commands and a lot of these dplyr functions. So here's just a quick table of some of the dplyr functions that are made available in that package. We can do an arrange, which just changes the order of the rows. A filter, which picks cases based on their values. So it'd be similar to like subset. Mutate, which is one of my favorites. It allows us to create a new column in a data frame or tibble based on calculations using existing variables in that data frame. We can pick variables based on their names with select. And finally, that summarize function that we saw earlier just reduces multiple values down to a single summary. So let's go through and see how these work. So this function, we'll use the arrange function to arrange Star Wars by height. So let's run this. All right, so first we're printing off the Star Wars. And because this is a tibble, it's only going to print the first 10 rows. And we're starting off with Luke Skywalker, C-3PO, R2-D2, Darth Vader, and so on. And then after, when we're doing arrange, we start off with Yoda, who apparently is the shortest one in this data frame, or tibble, excuse me. So with a height of 66. So probably centimeters, I don't know. Yes. All right, so this looks like our old way of doing it though, right? So if we want to do with the pipe-like operator, all right. So now if we take it and use this dplyr style syntax, taking Star Wars, piping that into arrange by height, and then piping that into a print function, we can see that we get similar results, or the exact same results rather. All right, any questions on arrange? All right, so let's look at filter now. This function is similar to subset, so it can be used to subset a data frame or tibble by keeping all the rows that satisfy a user-defined condition. So here we're filtering Star Wars, looking for the species that is equal to Gungan, and then printing off, just getting the head, so the first few rows of that. So if we run that, we can see there's only 3 rows. Jar Jar Binks, Ruse, Tarples, and Rugor Nass. I'm going to give you a minute. Can you convert that into the dplyr syntax or style, rather? And once you have that done, throw it in the chat, and we'll take a look. All right, hey Gabby, and Imran, and who's the other one? Zhao 5. Can you try logging into ACES again? Oh, Jin, that's okay. Jin Zhao. Y'all have been added to ACES. All right, has anybody converted this into the huh? All right, Miriam. Is that what is it the pipe? Whenever you type that into chat, does it automatically convert it?
Yes, I use the shortcut on the Mac, like Command Shift
Uh,
and it like shows the pipe like that.
oh, okay. I was trying to figure that out. All right, excellent. All right. I'm gonna grab Yu Ying's and throw this in here. All right, excellent. All right, yeah, so piping Star Wars into the filter function where we're grabbing just the species Gungan and piping that into head. All right, now let's take this off and print. So the output from head and print are going to look slightly different, and it's just a matter of styling. So just so you're aware, there are different ways to, of course, like we showed earlier, viewing and looking at the data sets. So it's just a matter of style. So if we even do this without using head, the output of a tibble is going to look like that, whereas print is going to convert it to look different. So again, a matter of preference, whatever you want. So, all right, let's look at this mutate function. Here, I am mutating Star Wars. And what I'm doing is I'm adding a column called BMI and setting that equal to mass divided by height, which was divided by 100, and then squared. So if we print this, all right, so now nothing's showing up. It doesn't look like, except for, oh, there it is. We have this new column, BMI, that is added to the tibble. All right, so see, starships here is the last one. Here, starships is the second to last, and we've got BMI as a value that's been calculated using the mutate. All right, so let's go ahead and we'll do the same thing. We're gonna convert this to our dplyr style. All right. All right. So if you want to select only certain variables or columns from the data frame or tibble, you can use this select function. It's going to return a tibble or data frame regardless of how many variables are selected. So here we're only selecting species and doing head. So it just prints out that singular column. If we want to select multiple columns, we can do so by providing a vector. So we can say name, species, and run this again. And now we've got Luke Skywalker's human, C-3PO is a droid, and so on. So once again, let's just go ahead and convert this into our syntax or style of dplyr. Uh-oh. Argument X is missing with no default. What did I do wrong? Oh, I forgot to pipe. All right. Well, I'm sure y'all figured that out. I did that on purpose, but I did that on purpose because I forget to do that all the time. So I wanted to show you what the output of that looks like, because that's a very common mistake that I make when chaining together these commands. All right, so again, now we're seeing those first 6 rows selecting just name and species. All right, I have got a large chunk of code here. to show you different things. So let's go through these one by one. Selecting multiple cells with the C combine function, which we just did. So here doing height, mass, and species. We can also just use the colon operator. Again, we wouldn't need parentheses around this because that's going to produce a vector without it. And so that's just going to print the first 5 columns. All right, and now we're getting kind of weird. But there is this functionality where if you want to select columns that end with a certain string, you can use this ends with function. Same thing with starts with. So this will pull everything that ends with the word color. This will pull everything that starts with the word S. All right, what does this do? Can anyone guess? There, it looks like it's an exclamation point, ends with color. This is a new operator for us. Although if you're familiar with Python or something, it should be, yep, everything but. So not, yes, all right, perfect. So yeah, you're negating that. All right, uh-oh. Now it looks like we have a real pipe. Or yeah, not just a pipe like. All right, so what this is going to do is get everything that yeah, or that's right, Jen. So starts with S or ends with S. And then this is they have to both start with S and end with S. So a lot of information in that little code chunk, but it seems like everybody's understands everything. So any questions on all those operators I just threw at you? All right. All right, so let's now look at the summarize function. So here we're taking iris, and what we're doing with iris in the summarize function is we're creating a new variable name and just making this simple calculation of the average of the sepal length. So if we run this and just take a look at the first bit, we can see now it's this sepal length, and it's just equal to the singular value. If we want, we can add in several different calculations. So here we're doing sepal length mean and sepal width mean. Okay. So 2 calculations. And we can also add in this n equals n in parentheses. And that gives us our sample size for what was used to calculate these values. Now, in and of itself, let me rephrase that. Okay, let me back up. So there are a lot of functions that will work really well with summarize. So mean, median, standard deviation, the interquartile range, all of these things, like max, min, all of those things would work really well with summarize. When I'm using summarize, I'm most frequently doing it by with or alongside this group by function. So is anybody familiar with the iris data set? I know we've got some biologists in here. Any familiarity with the iris data set before today? Some of us may have to think way back to our undergraduate days. Some of us may not have to think that far back at all. All right, it's a very famous ecological data set, but it contains 3 different iris species. So if we want to, whenever we're doing the summarize and getting mean sepal length and mean sepal width, it doesn't really make a lot of sense biologically because there's 3 different species in there, right? But if we do a group by and then tell it to group by that particular column. All right, so at first we just had a data frame with 150 observations of 5 variables. Then we did this group by on iris with species, and now we still have this 150 by 5 dimension data frame, but it's a grouped data frame. So it's a slightly different structure. And it is grouped by species. And so if we now combine that with our summarize function, and we're calculating all of these things, the sepal length mean, sepal width mean, and so forth, when we run this, oh, that's weird. Okay. Let me rerun that. All right, so now you can see it's calculating all these different statistics by species. And so automatically with something like this, I think the summarize function gains a lot more power, right? Whenever we're doing this group by just getting basic statistics. All right. All right, so now we have an independent exercise. It says in the code chunk below, create a new variable converting the mass from kilograms to pounds. Group the data frame by species, and then use the summarize function to print out the average of a new variable that you created. All right, so this is going to be using the Star Wars data set. So using the Star Wars data set, go ahead and I'll give you a few minutes to work on this. All right, so you'll need to do 2 different or 3 different 3 different functions that we've learned in order to complete this. So, and once again, whenever you're done, post your code in chat. And if you have any questions, post your code or ask your questions. All right, do we need more time? All right, Nick posted something. All right, let's copy Nick's code. I'm gonna throw it in here. All right. All right, so well, let's just go ahead and run this. All right, so kilograms to pounds, 2.2. That's right, right? So, and then we're going Star Wars mutate, right? So creating a new variable using mass and the value that they defined earlier. Then doing a group by the species. Summarize, and then we're saying mass pounds mean is equal to mean mass pounds, yes. And then into a print function, and we get this. Let's try running without the print function. All right. So just again showing those differences. All right. I don't know if this is a copy and paste thing or not. But did you notice that this worked correctly without the indentations? All right. And R is really unconcerned with things like indentations and spaces. The reason I use indentations is for readability. And if you come from a Python background, you're used to using indentations as well, where they're more important. So both, it works either way. So it's just a matter of personal choice there. Just out of curiosity, Nick, did you have it indented or not?
I didn't have it indented just because I was messing with it earlier and I realized it didn't make a difference.
Yeah, it
But
does.
I
So
can see both ways, I guess.
it's really, yeah. So it's personal preference there. But I did want to point out that the R is very forgiving with that, and I'm showing you certain ways, and it's just some of it may be my styling. And I'll point that out as we go along. So it was a good thing that worked out. All right, so we have a quick bonus, um, and that is just this na.omit function, and that will allow us to essentially remove everything that we had missing data for. So you can see we had a lot of NAs up here, and now those have been removed. So wanted to point that out. Let's see. All right, we have one more independent exercise. On a new data set, the MPG data set, which comes from ggplot2. So you're going to use head or print to look at the data, and then look at the data again and arrange the order of the data set by city. Filter this data set to only include cars with a manual transmission, and summarize the average city and highway values based on the class. So we're going to be grouping by class. All right, so we got about 5 minutes to work on that. And then we'll be taking a break for lunch. So I'll give you about 4 minutes or so to work on that, and then we'll go over the solution. All right. So it's 12:29. I'm gonna go ahead and just grab the solution from up here. Where it says solution, you can click on this if you get stuck, copy to clipboard and paste it. And then first we're doing a head of MPG, print, and then with an arrange the MPG by city. And then finally MPG and piping that into a group by class, piping that into a filter and grabbing the transmissions that is equal to either manual M5 or transmissions manual M6. And then piping that into our final summarize function. So here we needed to be familiar with the data set. And so looking at our first output print, we could see that we had at least these two different types of manual transmissions, manual parentheses M5 or M6. So you could have done transmission, you could have done a starts with there and done MAN. That would have been good. So actually, let's look at that real quick. What's the syntax for that? Never mind. We don't have time. All right. So it is now 12:31. We will be on lunch break until 1:30 Central Time. At which point we'll come back to importing and exporting data. I'm going to stay on for a few minutes in case there are any questions. But if not, feel free to go grab lunch, and we'll be back at 1:30.